Okay, in Chapter 3, we're going to work with the law of sines and law of cosines. Section 3.1 specifically is the law of sines. And in the other chapters, when we've dealt with our trig functions, they were all with respect to a right triangle. We had right angles in that triangle somewhere. And we talked reference angles, and we've worked with those for 2 chapters now. The law of sines and the law of cosines are nice because we can use them on any triangle. It doesn't have to be a right angle like the triangles we've been working with, but it can be an oblique triangle, something where there are maybe 3 acute angles, or maybe I've got an obtuse angle here, but none of them have to be 90 degrees. Okay. Also, I need to warn you that I'm not in Pratt anymore. I'm not on the smartboards. And so what I have is a tablet that's this kind of blank little thing off to the side of my computer. And when I move my pen on it, it draws on the screen. So this is going to look a little rough, but we're gonna make do because those are our options. When we have a triangle and we're labeling parts of it, we usually use capital letters for our angles, and we use lowercase letters for the sides. And so the side straight across from angle A will be side A, and straight across from angle B will be side B, and straight across from C will be lowercase c for side C. Okay, now your author does put the proof of this rule that I'm about to write up. He has it in your book, and I think it's a great idea for you to flip to that page, page 308 it says in our book, and to look through that proof, because it's really nothing too nasty or scary, and it's kind of nice sometimes to see where the rules came from. So if we were in class, we would probably doodle that on the board, but given our situation, we're just going to go to the punchline. If we look at side A, ooh, this is supposed to be a B, side A over the sine of angle A, that ratio is going to be the same as side B over sine of angle B. Okay, also the same as side C over the sine of angle C. And of course, when we're working with this, we're not going to have all 3 pieces here, but we're going to pick the ones where we know 3 of the 4, and then we can solve for the 4th one. The other nice thing about this relationship is if we would rather see it flipped upside down, we can do that. Sine A over A is equal to sine B over B is equal to sine C over C. All right, so as your author points out, if we know one side of the triangle, and then we know any other 2 values, whether those 2 values are other sides, whether it's a side and an angle, but we have to know one side, and then on top of that 2 more pieces of information, and then that's enough to use the law of sines to find the missing pieces of that triangle. So I copied this one out of your book. I had it ready to go a little bit ago. If you need to pause the video to write this down, do that before we start. But usually our goal is to find all of the missing pieces, along with whatever they've given us. So I'm going to make a list of everything here. And in some of the problems, instead of drawing you a picture, they just tell you lowercase a equals this, or capital A equals that. And it looks like we know that side B is 20. It looks like we know angle C is 105 degrees, and that angle B is 45 degrees. Now, of course, my favorite situation with the angles is if I know 2 of them, I can find the 3rd one without doing anything fancy there, because I know that the sum of the 3 sides of any triangle, big, small, right angle, not a right angle, whatever it is, they all add up to 180 degrees. So if we add B and C together, we get 150. If we subtract 150 from 180, we find out that angle A is 30 degrees. Okay. Now that's going to be the shortest one that we do in terms of the work. If I want either of the other two sides, we can use now the law of sines. Maybe I next want to try to approach and find side A. So if I want to know side A, I know side A over the sine of angle A is going to be either side B over sine of B or side C over angle C. And since I don't know side C, I'm going to go with the pieces I do know, which are the 20 for B and the 45 degrees for angle B. Ooh, come here, there. From there, if I want to solve for A, I can multiply both sides by sine of 30. Of course, if I wanted an exact value for this, let's do that on this one because these are special angles and it doesn't hurt to practice that. Sine of 30 degrees is equal to 1/2. Here we have square root of 2 over 2. So the top reduces to be 1. We flip and multiply. I say flip, but I didn't flip. Come here, up. And so we find out that once we rationalize the denominator, that side A is equal to the square root of 2. Okay, the author in some of the problems will tell you to round. It looks like in the first section in your textbook it says round to 2 decimal places. So this would be 1.41 if we were rounding. If we were asked for the exact value, we would give square root of 2. If I want to go back and find side C now, whoa, too small. Okay. Then I can do the same thing. I can say C over the sine of angle C, it's running away from me, is equal to, we can either use A over sine of A or we can say B over sine of B. It's always safest to go back to the black values, to the ones that our author gave us or whoever gave us in the problem, because if I made a mistake when I was finding, maybe I accidentally forgot to flip that 2 over square root of 2 to be this, and I left it the way I wrote it the first time, and I have a wrong value there. If I have a wrong value here, then I compound that error when I come down here and use it. So again, if there's a pair that you're given, both the side and the angle, that's the ratio that it's best to use. And if we have made no mistakes, if we're confident in our work, then it doesn't matter either way. Now, while I wrote these down before I turned on my video, I didn't actually compute what the values were. So if I've pushed the right buttons here, I get 2.87983 as it runs off the page. So to 2 decimal places, I would call that 2.88. I'm going to stop here and then make a new video and we'll do some other examples.